Hi folks, welcome back. I just wanted to make a quick video about what I've been working on lately. From some of my previous content, you can tell that I've been really getting into this idea of specialized harness engineering lately. And I'll leave links to all that below. I won't rehash all that content. But the idea is that I really think for most agents, for most harnesses, you want to construct a special purpose harness that is specialized to that particular narrow task or family of tasks, as opposed to using a fully open-ended general purpose harness like Claude Code or Codex or something like that. And that brings you a lot of benefits, both in terms of efficiency, of course, because with a specialized harness, you can use a smaller, cheaper model, but also performance, because if you specialize the harness, you narrow down the choices and the cognitive load on the model, you can get much better, much more repeatable, reliable performance. So in this video, what I want to talk about is something I've been working on lately, which is what I call a specialized harness compiler. And the idea is very simple, which is that I want to take some kind of a task description for a narrow specialized task. And this could include an SOP, a standard operating procedure, the tools and APIs this task might need, examples of both good performance as well as bad performance, the rubric by which you judge it, etc., etc. So this is just a description of a task. This is not a harness or a bunch of code trying to carry out this task. And starting from this task description, I want to build essentially a harness compiler that at the other end of the pipeline gives me a runnable harness. And in this process, at build time, the compiler does a bunch of hill climbing. So the way it works is from the task spec, it generates an initial harness. And from the examples and evals that you've given it, it then does hill climbing on it. So it runs this initial harness, it sees what failed, what passed, and it tries to improve it until it gets some good performance. And it tries to avoid overfitting by keeping a holdout set so that you don't just overfit to the training sample. And this basic idea is very similar to this paper called MetaHarness that I covered a few weeks ago, where what they were trying to do was take a harness and then kind of automate the benchmaxing loop around the harness. And that if you start with a harness and you're given a benchmark, the process in this paper would look at the failure traces and try to improve the harness. So it's very much inspired by this paper. I think the thing that's different about what I'm doing is that I don't even start from an initial seed harness. I start purely from a task description. I generate an initial harness, and then I do a bunch of hill climbing on this initial harness and I try to improve it. And what you're left with at the end is a standalone frozen harness, which is the output of this generation and hill climbing process. And so far, I've been seeing pretty promising results. I tried it on some example tasks from a few previous benchmarks I've been working with. For example, this one, the dangerous goods SOP comes out of SOP bench. There's a room booking IT support task that comes out of the AVA voice agent benchmark I looked at a couple of weeks ago. And then FNOL, first notice of loss, is kind of a very common agent use case for insurance use cases. And in all of these cases, this harness compiler was able to just take the initial task specification and do some hill climbing and come up with a harness that got pretty good results on the final benchmarks. The cool thing was that it was able to make the distinction between deterministic code and where to use LLMs for natural language understanding or structured data extraction. So, for example, in dangerous goods, even though you have an English language SOP, if you deeply understand the SOP, you can convert the entire thing to straight up code, just deterministic code. And it was smart enough to pick up on that. So this resulting harness is just straight up deterministic code, no LLM calls. If you take a hybrid harness which has both deterministic code for state transitions as well as LLM calls for natural language understanding. This room booking one is a good example of that because you have to do a lot of state management throughout this conversation, like what kind of room the person is asking for, what date, what time, how many people. There's all these little pieces of information you have to collect and do tool calls along the way. So there's a lot of deterministic code in this harness that does this state management and tool calling. But of course, you need an LLM to understand what the user is saying and to do structured data extraction from user utterances. So this is a good example of a hybrid. Same thing with first notice of loss, where you have deterministic code trying to collect this information and drive the conversation forward, but you're using LLM calls. And by the way, both of these cases, the resulting frozen harness just uses Google Flash, so a fairly inexpensive model. So yeah, I just wanted to make a quick video on this. I really think building specialized harnesses is a great technique to build agents and harnesses for these high frequency, commonly occurring tasks that happen in most enterprises. If you've had any experiences with something like this, would love to hear how it went for you. All right, I'll see you in the next one. Thanks.